Okay, for this challenge, we'll be implementing binary search. Now this is pretty important subject to master because many other variants, other coding challenges could have, let's say, sorted list or sorted array, and it's good to know this because to improve time space complexity for other variants could improve our time like greatly from O of n to logarithmic time, right? So for this coding challenge, we need to construct a function that accepts array and a target value. So let's say that in this case, our target value would be 5. And what we need to return is an index. So because this is zero based, we return 4. And for the other example, so let's say that we're looking at target 8. In this case, we would return index -1. So we didn't find our target, right? And there's a twist. We need to implement the function both iteratively and recursively, right? Okay, so let's do that. So we'll have an array from 1 to 7, and let's print, so find it as our function, and print our target, which can be 5. In this case, we would return 4. If the target is 8, we will return -1 in this case. Cool. So let's first implement iterative solution. After that, we can do recursive one. So find array and target like this. For iterative solution, we just have 2 pointers. We have left and right pointer. Left points to 0, right points to the last index, which is length array -1, this. And then while left is less than or equal to right, we always calculate mid pointer, which is this left plus right minus left divided by 2, like this. And then we just need to check if mid pointer points to what's the target. If so, return mid index like this. Elif if the mid pointer is less than target, what do we need to do? If it's less than target, we need to move pointers. So left pointer goes mid plus 1 like this. Else we know that mid pointers is bigger than the target, so we need to move right pointer mid -1 like this. Cool. After we're done with while loop, if we're still in this line, then we know that we haven't found our target, and we can just return -1 like this. Clear the output and run the code. We see that we get 4 -1, which is what we expect. Cool. And the next one. Oh, let's talk about time space complexity for iterative solutions. So for time, we could say that it's log n, and for space, it's just O of 1, right? We have just few variables, and that's it. We're not building any additional array or anything, right? Nice. In the last iteration, we will implement recursive solution. Cool. Let's first implement the function. So find, we have array and target. Let's have just a helper function. Just return recursive function a target, and the first parameter here will be left index. So left pointer and right pointer is the last index, which is length a -1 like this. Cool. Let's implement this helper function. Left and right. Because this is a recursive function, we need to handle base case, which is if L is greater than right, we know that we haven't found our target, and we can just return -1 like this. If we're on this line, we need to calculate mid-pointer, which is this left plus, so right is bigger one minus L, and just divide by 2, like this. Cool. If mid-pointer equals to target, we can return mid. If not, leave. We need to check, is it bigger or smaller? Let's do it here. Let's say a mid is bigger than target. We return and call recursive function a target. Okay, and because a is bigger, left is the same, but right moves to mid minus 1, like so. Else we need to move left pointer mid plus 1, but right pointer stays the same, like this. Cool. So let's run the code, and it works. Awesome. So yeah, these are solutions for, let's talk about time space complexity here, right? So for the time, it's logarithmic, right? It's still logarithmic, like in the iterative solution, but for space, we would think that it's all for 1, right? But because we are using space on a call stack every time we call a recursive function, right? It's actually the space is also log of n. Yeah, and that's it. These are both solutions for implementing binary search. Yeah, thanks for watching, and till next time. Bye.